Hi, first of all, I would like to thank you all for coming to my talk, and I hope you will enjoy it. In this talk, I'll explain how we touch the holy grail, load testing in production, while minimizing risk and human intervention. We'll go over the gainings, trade-offs, and what it costs. We'll elaborate on how automated load tests drove a deeper culture shift by increasing developers' confidence in their services, promoting more complete service ownership, all of which with almost no additional overhead to the developers. Lastly, I'll provide more insights into the service that made it all possible, highlighting the obstacles we encountered along the way and the remarkable achievements we have reached. Hello everyone, my name is Slava Antonenko, and I'm a SRE engineer. I've been part of Outbrain for 2.5 years and with 8 years of experience in the industry. Since I joined Outbrain, my focus has been on developing tools to support and ensure the reliability of our ecosystem, including the implementation of load tests, which we'll discuss in detail shortly. A little bit about myself beyond the professional introduction. I'm married plus cat. I love sports, in particular Formula 1. During my free time, I love competing in our local online racing league using the official Formula 1 game. And lastly, I can spend the winter without skiing in the Alps. Before we dive into the technological narrative, let me provide you some insights into Outbrain, allowing you to gain a better understanding of the scale and scope of our operations. This will ensure that all pieces come together seamlessly and provide you with a complete perspective. Clicker stopped working. Outbrain is a world-leading recommendation platform for the open web, with 1 billion monthly readers and 344 billion monthly recommendations. To give you a clear picture of our product, imagine a widget that is integrated into well-known content websites like CNN, Sky News Times, among others. You can see it on the screen highlighted in the orange color. Normally, it can be found at the bottom of the page, right after the article you read, or sometimes also on the side of the page, like here. Whenever a user loads an article on these websites, our widget sends a request to our servers to retrieve personalized content recommendations based on users' profile and interest. As more and more people browse the internet and engage with articles, the load on our servers increases accordingly. Let me ask you something. Who is staying up to date by visiting their favorite website at least once a day? It can be news, sports, basically anything you like. Keep your hands up for a moment. Who did not hear about the Will Smith, Chris Rock thing and the Oscars last year? You know, this thing. That's what I thought so. Major events like these can cause significant spikes in traffic to the Outbrain platform. To ensure that we are always prepared for such situations and maintain an optimal performance, we conduct a lot of load tests. Additionally, we prioritize being well prepared to handle any potential disaster recovery scenarios. At Outbrain, we operate within a microservices architecture. Each team takes full ownership of their services, from development to production. This means that if there is a production issue with a particular service, the responsible team will receive a PagerDuty notification to address the issue right away. The same principle applies when conducting load tests. Teams are accountable for their services and actively participating in the testing process if necessary. Okay, done with formalities. Let's go and learn about load testing and production. Now, I want you to imagine you driving a car, and like any other car, it went through crash testing before mass manufacturing and shipment. Now, imagine these crash tests were done on each part of the car separately, crash testing the wheel, the door, the seat, the engine, by throwing them against the wall one by one. I think you can agree with me that it's not a real crash test, but it can be fun to watch. Would you still drive such a car? Not so sure. Same with load testing and production. Conducting them on each part of the product separately can have some insights, but does not reflect the true state we aim. Moreover, having load tests on a real-time data is the best simulation you can have. It helps you to increase your predictions and business performance and boost your ecosystem reliability massively forward. Conducting load tests in a test environment falls short of capturing the true reality we aim to simulate. The components in a test environment often differ from those in the production due to variations in versions, data clusters, and other factors. Load tests performed on individual components, such as those in CI/CD pipelines or on clusters of smaller sizes, fail to accurately reflect the challenges and issues that exist in the actual production environment. When conducting load tests in the production, we face significant risks that must be considered. We can lose the entire data center. As we generate substantial load of system resources, there is a possibility of exceeding CPU and memory limits, leading to a failure in serving the expected traffic. This poses a high impact on customer experience, potentially resulting in a degraded experience or even no experience at all. As a result, there is a considerable risk on revenue and income due to the effects on performance and customer experience. We choose to embrace the risks associated with conducting load tests in a production and testing the ecosystem as a whole, where all components are actually serving real traffic and tied together. We carefully monitor and schedule these load tests to ensure an optimal execution. Creating a test environment that perfectly replicates the production environment, generating the same level of traffic, would be much more expensive and still not provide the same level of accuracy, because synthetic generated traffic hardly represents the true pattern of production loads. The benefits and costs of production load tests outweigh the alternative of investing in an exact replica test environment. Now, let's cover our ecosystem and its scale and address how load testing was traditionally managed at Outbrain. We work hybrid and have a combination of 3 big data centers located in the US, small data centers, and public clouds. Our traffic distribution is managed across 3 data centers based on 2 criteria: geographic proximity and a balanced load distribution. For example, traffic from Japan is directed to the data center located on the US West Coast, while the overall traffic is evenly distributed among the data centers. To facilitate this traffic shift, we have our internal traffic shift system that allows us to move countries' traffic from one data center to another when necessary. During a load test, we select a specific data center and gradually moving countries to it until we reach the target traffic volume we have set, and then we assess the data center's ability to handle the increased load. If any issues arise during the test, we can quickly stop the process to prevent any impact on the production environment. How to determine the target traffic for the test? We have experimented with various methods to establish an optimal target for cost and performance. The higher the target you set, the more stable your product will be at high traffic. However, such traffic will incur in higher costs, and the ecosystem may not even require such scale. Therefore, we need to find the optimum point. The method I recommend is more of an equation, where the parameters should be set based on the patterns, business, and goals of each product. Let's define X as a specific time frame and consider the maximum traffic the product experienced during this time frame in all data centers combined. For instance, when X is 1 month, we can look at the highest traffic observed in the last month. Next, let's define Y as the number of data centers supporting the product. In the event that one of the data centers fails, we must ensure that the maximum traffic can be supported with Y minus 1 data centers. Hence, the simple equation would be max traffic during X period of time divided by the number of data centers minus 1 plus delta. Here, delta represents the safety buffer for handling the highest traffic. It's important to note that the equation can be adjusted based on the infrastructure and business needs of the product. However, it provides a clear guidance. We must consider that as X, the time frame, becomes smaller, the risk of failing during peak traffic and missing the actual target increases. Ultimately, the decision depends on cost. Our ecosystem is very complex and constructed from a lot of microservices and various data systems. Here's how it looks, so you can get the feeling of the complexity and scale of the environment we are talking about. These dots are production services, very complex as you can see. Prior to February 22, load tests were conducted manually, which had the possibility of human errors. The process involved an extensive preparation and the involvement of at least 10 engineers who dedicated their time to monitor dashboards and identify potential issues. This manual approach resulted in a significant waste of time that could have been better utilized. As a result, we were unable to conduct an optimal number of load tests. To address this challenge, we recognized the need to transform our manual decision-making processes into automated solution, essentially creating a self-service framework that operates on autopilot. We have chosen not to rely on third-party tools for conducting load tests in order to maintain maximum flexibility and control. We have explored various options, but haven't really found a tool that fully meets our specific requirements. It's important to emphasize that conducting load tests in a production environment carries a certain level of risks. Therefore, having maximum control over the testing process is crucial. Mixed up a little bit. It's important to emphasize that conducting load tests in a production environment carries a certain level of risk, as it can potentially impact customer experience. Therefore, having maximum control over the testing process is crucial. While we acknowledge that production load tests incur costs and consume a portion of our budget, we firmly believe that the benefits and the achievements gained from these tests exceed the associated expenses. We operate within a limited resources, and when our systems approach capacity during load tests, the integrated throttling mechanisms we have kick in to maintain stability. This means that under heavy loads, our algorithms may not perform optimally, and therefore customer experience can be degraded. But it allows system resilience and identify any potential issues. Now I'm going to share with you the service that makes it all happen, that takes the concept we talked about into a service that works automatically and efficiently. Sorry for keeping you in suspense. Let me introduce you to Lotar, Load Test Automation Runner, our automated system for managing and executing load tests in the production. Lotar, a backend service, remains idle for the majority of the time, only activating when the load test is scheduled. It operates on an automated basis, initiating load tests at designated times. Once a load test is completed, Lotar automatically collects and stores the parameters used during the test. This enables the seamless scheduling of subsequent load tests without manual intervention. In case where an off-schedule or emergency load test is required, the service can be started promptly through an API call or Slack command, providing the flexibility to conduct tests as needed. When is the best time to conduct production load tests? Determining the optimal timing for conducting load tests in a production requires a careful consideration. Unlike load tests in a controlled test environment, any issues encountered during production load tests demand an immediate attention to minimize the potential impact on customers and revenue. To facilitate quick resolutions of such issues, it is recommended to schedule load tests during working hours, when engineering teams are instantly available to address any emerging problems. Moreover, it's crucial to avoid initiating load tests when there are ongoing anomalies in real-time traffic or other instabilities within the system. This ensures that the load test can be conducted in a stable environment and provide accurate insights into the system performance under normal operating conditions. With these considerations in mind, let us take a look into the automated load test steps. To ensure that the Lotus service operates during designated working hours and avoids running during nights or weekends, it uses a pre-configured time slots. These slots provide control over when the service is active. Before initiating a load test, the service performs a series of checks to verify the overall health of the ecosystem. This includes validating the operational status of essential third-party systems such as databases, Prometheus, Slack, PagerDuty, and others. Ensuring the functionality of these dependencies is critical for the smooth execution of the automation. Additionally, a crucial aspect of the testing process is to conduct a health check of metrics and monitors of the targeted data center. Okay, everything is fine. We can start creating a load. As I mentioned earlier, the process of traffic shifting plays a crucial role in our load testing approach. Specifically, we use this technique during the data center warming up phase. This step involves gradually moving countries to a designated data center until we reach the pre-configured target traffic level we have set for ourselves. By incrementally shifting the traffic, we can carefully assess the performance and capacity of the data center under increasing load conditions. Great, we're at target. What's now? During the maintain step, as the name suggests, our focus is on preserving the state of the data center under high traffic conditions. This phase is essential for ensuring that the data center can sustain the increased load without any issues. Typically, we maintain the high traffic state for slightly over an hour, allowing us to assess the stability and performance of the hourly processes during this period. To support this process, the service wakes up a sub-service called Traffic Balancer. Its responsibility is to ensure that the data center maintains the desired target traffic level. This component is critical because our traffic originates from different countries around the world with varying time zones. As some regions go to sleep while others wakes up and something happened to the presentation. Yeah, it's good. It went to sleep, exactly. Some regions go to sleep and others wakes up. The traffic patterns are accordingly. Therefore, it is important for us to closely monitor any spikes or reductions in traffic in order to maintain the data center at the target traffic. And the last one, cooling down step, really simple one. All countries are returning to their original data center. Doing a load test in a production environment is a risky thing to do. The thing that we are doing for 8 years already and for some period automatically. In order to mitigate this risk, when we move to an automated system, we have created a setup and control process. So how do we do that, protecting our production environment during a load test? As I previously mentioned, we follow a distributed ownership model, where each team is responsible for their respective services. To support this responsibility, we have implemented a process that allows engineers, as well as the automation, to make decisions based on the severity of the problems encountered. This ensures a collaborative approach to problem solving and empowers teams to take appropriate actions during the process. During the whole execution of the load test, we monitor all services, selected metrics, and KPIs. We have implemented the traffic lights method to categorize alerts based on the severity. Severity 1 alerts indicate a significant decrease in the company profit as a result of a problem, leading to an immediate automatic abort of the load test. And again, let's wait for the slides to come up again. Severity 2 alerts indicate a serious problem that impacts the profit to a defined threshold, prompting the service to pause the load test and divert some traffic away of the load tested data center. This allows time for investigation and resolution by the engineers. And severity 3 alerts indicate a potential problem that could escalate. The automated system is keeping the current state and notifying the relevant team to address the issue in real time. This approach helps us to prioritize and address issues based on their severe impact and urgency. The alert architecture we have in place is designed to ensure prompt detection and response to issues during the load test. The service actively monitors our internal alert system, Antonenko, which is a Prometheus setup metric system, for metrics that exceed thresholds, triggering and pausing the load test. By the way, the elephant logo in the middle is the Lotar logo. We took an inspiration from this well-known image. Additionally, interactive Slack messages are sent to relevant team to notify them on the issue and initiate investigation. If the team does not acknowledge the alert within a few minutes, the on-call engineer will receive a PagerDuty notification. If there is still no response, the issue will be escalated to the SRE team for further assessment. In the worst-case scenario, if the issue persists and poses a significant risk, we may have to make the difficult decision to abort the load test. While it's crucial to conduct load tests in production, we prioritize the stability and reliability of our systems, ensuring that any issues are addressed within a controlled time frame. Slack plays a crucial role in our communication ecosystem at Outbrain, serving as our primary channel for collaboration and information sharing. We leverage the powerful capabilities of Slack to automate decision-making processes within our load test automation. The service emits status messages directly to Slack channels, providing real-time updates and notifications to relevant teams. When an issue is detected, interactive messages are sent to team channels, requesting an immediate attention and response. Additionally, we utilize Slack commands to perform various operations in real time, such as pausing, resuming, ending load test, and even modifying configurations on the fly. This integration with Slack empowers teams to efficiently manage and visualize in real-time load test processes, improving collaboration and agility in addressing any arising issues. Here is an example of an alert that was detected by our load test automation and sent to a designated Slack channel of Team X. The alert message provides a clear sequence of events, allowing the engineers to understand the context and take appropriate actions. With interactive buttons embedded at the bottom of the message, engineers can easily send automatic commands back to the service, enabling an efficient and immediate response. This is so convenient that sometimes I'm interacting with the load test using my phone if I'm not near the laptop. Basically, Slack has become our user interface and serves as our primary front-end for managing load tests and interacting with our automated system. Okay, you now know how the past looked like and how the present looks. Let us now dive into the outcomes and benefits we have obtained from these efforts. We felt an immediate impact in several aspects. By increasing the frequency of our load tests, conducting them 4 times more often than before, at least 8 times a month instead of 2, we have adopted a proactive approach that quickly detect and address issues within days rather than weeks. This accelerated process resulted in a faster problem identification and enhanced overall system reliability. Furthermore, the implementation of automated systems has proven highly effective in swiftly identifying issues, significantly improving our mean time to detect, MTTD. As a result, we are now able to address and resolve issues more promptly and efficiently. This reduction in MTTD has had a direct impact on minimizing revenue loss caused by potential issues that may arise. Our automated systems have played a crucial role in enhancing our overall operational efficiency and ensuring a smoother experience for our users. In the past, we used to waste approximately 15 hours of valuable engineering times due to Zoom meetings where engineers had to monitor their services during load tests. However, with the implementation of our automated load test system, this time-consuming process has been drastically reduced to almost zero. The efficiency gains exceeded our expectations, and we owe this success to the collaborative efforts of our dedicated engineering department. The introduction of automation brings about a significant cultural shift in how we approach problem solving and system maintenance. With automated tools in place, the focus shifts towards addressing issues at the root, ensuring that the system operates seamlessly without the need for manual intervention. A concrete example of this culture change can be seen on some of our A/B tests. Previously, those A/B tests would be manually turned off and then back on again once every 2 weeks during load test. However, with the implementation of automated load tests taking place at much higher frequency, our R&D team took the initiative to develop automations to handle this process without any human involvement. This shift towards automation inspires greater confidence in stability and reliability of our systems, as we rely on automated solutions to efficiently manage critical tasks and maintain a clean environment. We went from this to this. Basically, what we do now are more important stuff like relaxing, drinking beer, and watching how the load test runs automatically by itself. Until now, I've loaded your brain with information about load tests in production, discussing topics such as manual versus automatic processes and the what and how of conducting these tests. However, load tests go beyond simple starting, ending, and reviewing results. By performing load tests in production, we have gained the ability to empower them. These tests are not just isolated experiments. They serve as a centralized platform for making informed engineering and business decisions. Load tests in production provide insights into our desired state, capacity, service performance, and more, offering us a wealth of valuable data. We take this data and analyze it. Through this analysis, we'll gain a better understanding of our ecosystem to make informed decisions. This data analysis project is still ongoing, as this valuable data holds great potential and offers numerous possibilities. We are always exploring and discovering new opportunities within this realm. Some examples of the data we are storing includes resource utilization of ingress, VPN, gateway instances, also collecting all alerts that appeared during the execution, and more useful information. The direction you choose to take with load test insights depends on your organization needs and goals. I like to share some of the directions we have decided to go with, as they may inspire you and provide ideas for your own initiatives. One exciting development on the horizon is load test comparison. Our goal is to compare data from previous load test runs with the latest one and identify any anomalies. This proactive approach will allow us to raise flags to relevant teams and identify before any potential issue can negatively affect us. It is a significant step in ensuring the reliability and stability of our systems. During load test, our Kubernetes clusters experience a significant but not necessarily maximum load. In the worst case scenario, when we lose one of our data centers, we can anticipate the state of our system based on this data. This allows us to make more accurate estimations for quarterly and yearly hardware purchases, as we serve most of our traffic on-prem, and efficiently allocate resources. Based on this data, we can identify resources with low utilization at high traffic, creating detailed reports for running teams to assess and free available resources. Another intriguing aspect is when our Kubernetes cluster reaches its maximum capacity during load test, resulting in service failures due to resource limitations. However, this presents an opportunity for our engineering teams to think creatively and find ways to optimize and improve their areas of responsibility. By reducing resource utilization in their services, they can overcome the limitation imposed during the load test. This provides an exciting point of reflection and encourages innovative thinking. Scaling an automatic system like the one we have implemented at Outbrain is relatively easy, particularly for medium to large companies. When a new service or team is introduced, such as in the case of inquiring a startup, integrating into our low-test procedures requires only a few straightforward steps, such as configuring a new Teams alert Slack channel. When the entire ecosystem is being tested as a whole, releasing a new technology or service by putting them in production means that they are now also part of the low-test cycles, ensuring its compatibility and readiness to handle the anticipated traffic. With our established framework and automated tools in place, the onboarding process for new services is streamlined and efficient. This scalability enables us to quickly adapt to changes in our technology landscape and effectively incorporate them in our low-test procedures for providing the best customer experience. While it's true that conducting load testing in production carries risk, we approach it with a sense of responsibility. We understand the importance of promptly addressing any issues that may arise during the process. In some cases, we encounter challenges during load tests that do not have an immediate solution. When faced with such situations, we make the difficult decision to abort the load test before their completion, aka a failure, acknowledging that we're unable to achieve our goal of sustaining high loads in a particular data center. On one hand, it's indeed a failure, but on the other hand, it's a success, because at the end, the load test met its main goal, and it is to find the problem before it will really hit us, and this is what it's all about. Before we're ramping up, I would like to take a moment to thank our head of SRE, Nir Chris, who is playing a huge role in the thing that is called load testing in production Outbrain, and who also helped me create this talk. I hope I help you to gain a new perspective on load test and convince you even a little bit that conducting them in production, it's not so crazy after all. And I really recommend you to try it yourself and see what kind of great things it can bring to you. Thank you very much.